your common ratio is actually a number multiplying. Your common ratio is actually the number that you're multiplying with the terms. Okay. And you can kind of see that happening. So right here, if I have a sub 1, I multiplied that with r. There's the common ratio, the r. And then to get my next term, what did I do? I multiplied with r again. See it? And then what did I do? I multiplied with the r again. So your common ratio is a specific number that you just use to keep multiplying the terms. Okay, that's kind of all it is. All right, so let's take the 2 and the 8. Now, remember that first r where we had the a being divided by, a sub n being divided by the a sub n minus 1? That's what we're going to do right here to figure out if, in fact, this is geometric. So I'm going to take the 8, and I'm going to divide it by the 2. And that would give us a what? 4. I'm going to do it again, just to make sure that we have a common ratio. So now take the 32, divide it by the 8. Do we still get a 4?
Yes.
And let's do our last one. So the 128 divided by the 32. Will that also give us a 4? Yes. Okay. So this is a geometric sequence with a common ratio of what? 4. Okay. Our a sub 1 is 2, and our ratio is 4. Okay. Questions on that? Okay. Let's try B. So B, we're going to have the summation of 3 raised to the n plus 1. So I want to list the first term and the common ratio. So how would I find my a sub 1? I'm going to substitute that in. Thank you. All right, so my a sub 1 would be, I guess in this case maybe s, but okay, 3 to the 1 plus 1, which would be 3 squared, which would be 9. Then what do I need to do to find the ratio? I know I need to find the a2, so then we can, okay. So a2, so that's going to be 3 to the, what? Yes, 2 plus 1, or 3 to the third, which would be a what? 27. Now, let's divide that out. 27 divided by the 9 is what? Is 3. Okay. Let's come back to what we initially started with. We have a 3 here. Are we raising 3 to an actual power? Is 3 being raised to the power of n plus 1? Yes. Is 3 being raised to a power here and here? Yes. You think you can figure out what your ratios are? They're the what? They're the base that's being raised to the power. That's a pattern. So as we're working through these problems, look at it and see if you can figure out what the ratio is, okay? All right, so we had, then on this one, we had a ratio of, common ratio of 3. And then the a sub 1 over here of 9. Okay? And what kind of formula is this again? It's the what? Perfect. Okay. All right, so write down your sequence. Your sequence here is 3, then 2, then 4/3, then 8/9. We're going to do 3 things. We'll just start off with the first one. First thing we're going to do is we're going to find the nth term. So essentially, we're just going to find the explicit formula for this, finding that nth term. Okay? So if I'm looking at this, I can see my A1, in fact, is what? 3. So it's nice when it's listed, right? We can find it. However, we do need to find the r. So if I have my first two terms, how do I find the r? Divide. Divide. Which one do I divide? I divide the second term over the first term. So 2 divided by 3. That's pretty easy then. It would just be 2/3. Okay? So there's our a sub 1, and there's our ratio. So let's put it into our formula. So a sub n would be our a sub 1, which we found to be 3, times our 2/3 raised to our n minus 1. So that's the nth term. We don't know what term we're finding, so we leave it. We're done with that, right? We're good. Now, however, what are we going to do for b? We're going to find the what? The ninth term. So until you establish your nth term, your explicit formula, until you establish that, you can't, right? You can't find each term. Now we can find each term. In this case, let's find the ninth. So we're going to find a sub 9 equals my a sub 1, which we found to be 3, times that ratio of 2/3 raised to the n minus 1, which would now be
8.
Very good. Do you see we're doing the same thing we did with arithmetic? That our term is always one less than the... Perfect. Okay. So now let's do this. So now let's take your 2/3, raise that to the 8th power. So let's leave 3 on the outside. What is 2 raised to the 8th power? 256. And what is 3 raised to the 8th power? 65, 60, is it 65, 61?
Yeah.
Is that right?
Yeah.
Okay. It's not working. So 65, 61. Okay. And then we can go ahead and multiply the 3. The 3 is in the numerator. So what's your 3 times the 256?
768.
So 768 over your 65, 61. There you go. Okay, so to do our recursive formula, we always start with a sub 1. In this case, our a sub 1 equaled the 3. And then our a sub n equals our r, which was our 2/3, times our terms. Our terms in general are a to the n minus 1. And just a reminder, this right here, remember that's just each successive term, right? That's each term that keeps getting dropped in. Okay? Because remember with recursives, we take what we found the previous term, right? Remember we take the previous term and we drop that in, right? And then we multiply it by that common ratio. Then when we get that number, what do we do with that number? We drop that back in. Okay, this is how money grows, right? Let's say you started with $100 in your account, right? And you were making 3% interest. Okay, so you would multiply that $100 times your interest. You'd make how much? You'd make what, 3 cents or something? And then you drop that in here, and you do the process over again, right? So this, recursively, that's how money makes money, right? Once you get a total, that new total gets dropped back in, and it just continues to compound, right? That's how it compounds. It compounds using recursive formula. So that's why your recursive formula is important. Okay, so we're going to take our summation formula, which is this one right here that I had you highlight, and we're going to find some sums. Okay. Okay, let's do this one. Find the sum of the first n terms of the sequence 3 to the n power. Okay, so here we go. So in order to use our formula, we need to find what? What do we need to find? And? Okay, so let's do that. So all the information we have is that it is a 3 to the n power. So how can I find a sub 1? Excellent. So that would give us 3 to the first power. So a sub 1 is 3. How am I going to get my ratio? Yep, we need a2. Very good. Very good. Okay. So a2 would be 3 to the second power, which would be 9. Now, what are we going to do? Divide. Awesome. 9 divided by 3. That's our R. 3. Okay. All right. This question came up yesterday. Will my first term always, will my a1 always be the same as my ratio? No, this is just kind of a fluke. So, no, that won't always happen. All right, you guys, you're ready to just, let's bring this up and let's just drop everything in. So our summation, our a sub 1 we found to be 3. Okay. And then on the inside, 1 minus our ratio we found to be 3 too, right? Yeah, 3 to the n over 1 minus the 3. We are finding the sum of the first n terms. Since we do not know what this n is, we're not going to get a numerical value. We will just get a formula. We can do some simplifying, though. What can we simplify in here? What can we do? We can simplify that. So that would be what? -2. So on the outside, so let's do that. 1 minus 3 to the n over -2. Now what can we do? What can we do with the -2? Yeah, we're going to bring it to the outside. This again is what? 3 over 1. So when I move this -2 out, what am I going to have on the outside? -3 over 2. And then on the inside, since we've pulled that on out, then we just have the 1 minus 3 to the n. And that's all we can do, right? Unless they told us to find the sum of the first 20 terms or something like that.